Let us solve OpenStax University Physics, Volume 1, Chapter 4, Problem 34. A marble rolls horizontally off a tabletop 1.05 meters above the floor and lands 3.9 meters from the table. We will find its time in the air, its launch speed, and its speed immediately before it hits the floor. The key is that horizontal and vertical motion share the same time but obey different component equations. Start with a picture. Put y equals 0 at the floor and take upward as positive. The marble begins at y naught equals 1.05 meters. Because it leaves the horizontal tabletop, its initial vertical velocity is 0. Horizontal launch does not mean 0 total speed. Air resistance is neglected, so ax is 0 and ay is negative g. These choices make the signs in the equations visible rather than memorized. Begin with the vertical equation because every vertical quantity except time is known. At impact, y is 0. Substitute y naught equals 1.05 meters, v naught y equals 0, and acceleration equals negative g. Solving 0 equals 1.05 minus 1/2 gt squared gives t equals the square root of 2h over g, or 0.463 seconds. Gravity determines the fall time. The unknown horizontal speed does not enter this step. Now use that same 0.463 seconds in the horizontal motion. With 0 horizontal acceleration, displacement equals constant horizontal speed times time. Therefore, v naught x equals 3.9 meters divided by 0.463 seconds, or 8.43 meters per second. The word same is important. The launch and impact are one pair of events, so their elapsed time is the same in both component descriptions. Immediately before impact, the horizontal component is still 8.43 meters per second. The vertical component has changed under gravity. Vy equals 0 minus g times t, which is negative 4.54 meters per second. Negative means downward in our coordinate system. Draw these perpendicular components head to tail. The solid diagonal is the actual impact velocity. The components are its legs, not three separate velocities. Speed is the magnitude of the velocity vector. Because the horizontal and vertical components are perpendicular, apply the Pythagorean theorem. The square root of 8.43 squared plus negative 4.54 squared. The impact speed is 9.57 meters per second. It is larger than the horizontal component alone, as it must be after gravity has added a downward component. The reusable horizontal launch strategy is to draw the motion and choose axes. Use the vertical motion to find the shared time, and then use that time in the horizontal equation. At impact, determine both velocity components and combine them as perpendicular legs to find speed. Keeping the component equations separate until the final vector calculation makes the reasoning visible and prevents formula hunting.